Good day, viewers. Today's class, we shall be looking at operations with integers. Operations with integers or operations with numbers. And for us to look at this successfully, the concept of BODMAS will still be needed in our discussion. Then you also need to know this particular concept. Minus times minus will give us plus. Minus times plus will give us minus. Plus times minus will give us minus. Then plus times plus will give us plus. So if you are to make reference to our previous classes, you discover that while we're discussing fractions, types of fractions, we make best use of BODMAS, bracket of division, multiplication, addition, and subtraction. So today's class, by the end of today's class, we should be able to perform operations with numbers. We should be able to solve questions on exponents. We also look at some other concepts during the course of the class. So let me read out the introduction from our study material. The set of integers contains the whole numbers and their opposites. Zero can represent ground level with a room above and below, such as the rim of the Grand Canyon or the edge of a body of water. Zero can also represent a starting point, and integers represent moving forward and backward. Integers is a set of all numbers and their opposites. An object moving forward or up can be represented by a positive integer. When an object moves backward or down, a negative integer is used. So when you talk of an object moving up or down, moving up, moving down. Moving up represents positive, moving down represents negative. It can also be in this format. This one represents positive, this one represents negative. If you take a good look at this, you can see that when you are moving up and you are moving down, so they are in opposite direction. Up and down is the opposite direction to up. Forward, backward. Can you see that? So this is forward movement, this is the reverse movement. That's why it is negative. If I play a ball now, this is a ball. This is a ball moving towards this direction, and there's a wall. As soon as the ball hits the wall, it will rebound back in an opposite direction. It will rebound back in an opposite direction. So it means that if this ball is moving maybe with a speed of 2 meters per second initially, and it rebounds back in the same speed. So for it to rebound back in the same speed, it means that it's going to be negative 2 meters per second. It's moving back with the same speed, but in an opposite direction. So this is what the introduction is trying to tell us, that when you move up, it denotes positive. When you come down, it denotes negative. So let's look at some of the examples in our study material. Example 1. What is plus 12 plus minus 5? What is plus 12 plus minus 5 in brackets? Plus 12 is in brackets. Minus 5 is also in brackets. So don't forget, for me to remove the bracket here, I will multiply. Plus times minus, and we said earlier that plus times minus equals minus. So plus times minus is minus. So that is going to be minus 5. Then I bring down this plus 12 in bracket, plus 12. So plus 12 minus 5. I have 12 naira, but I'm owing someone 5 naira. Negative in this sense denotes indebtedness. I'm indebted to the tune of 5 naira, but I have 12 naira. By the time I pay 5 naira out of the 12 that I have, I'll still be left with 7 naira. So which is plus 7, or you say ordinary 7. So plus 12 minus 5 will give me 7, or plus 7. So let's go to the second example. The second example, I think there's an explanation for this first example. Let me read it. Think of a hot air balloon rising 12 feet, then coming down 5 feet. In the end, the balloon is 7 feet higher than it started. It means that you are still going to subtract. That's what it means, subtraction. So they are trying to give us an illustration using a rising balloon. Let's look at the second example. Example 2. Example 2 is what is minus 9 in brackets minus 2. Minus 9 in brackets minus 2. Just as we did in the first example, we repeat the same thing here. Minus times minus. From what we have, minus times minus is plus. Then I bring down the 2. Then minus 9 is in the bracket. I'll bring it down. Minus 9 plus 2. I'm owing 9 naira, but I have 2 naira with me. So by the time I pay 2 naira out of the 9 naira I'm owing, I will still be owing a sum of 7. That's minus 7. So minus 9 plus 2 is minus 7. That's the second example. Now, let me read this introduction also regarding multiplication for the next examples. When multiplying and dividing two integers, the sign of the result depends on the sign of the numbers being multiplied or divided. When the two numbers have the same sign, as in minus and minus. I repeat, when the two numbers have the same sign, the result will be positive. So let's take a look at that statement. Minus times minus is the same sign and it's giving us positive. Plus times plus is the same sign and it is giving us positive. That's what the statement means. Then when the two numbers have opposite signs, the result will be negative. Now, when the two numbers have opposite sign, as in the case of minus and plus, there are two opposite signs, the result will be negative. Is on the board. Plus and minus, there are two opposite signs, the result is negative. So this is the analysis of that statement on the board. The analysis of the statements are just read. So let's go to the next example. Example 3. Example 3 is saying What is plus 6 times minus 2? What is plus 6 times minus 2? So plus 6 times minus 2. Okay, plus 6 times minus 2. Now we'll multiply. How do we multiply? So we are going to open the bracket. Plus times minus. From what we have on the board, plus times minus is minus, because there are two opposite signs. Plus times minus is minus. Then 6 times 2 is 12. That's going to be minus 12. Minus 12. That will be minus 12. Plus times minus is minus. 6 times 2 is 12. So our answer is going to be minus 12. Let's move to the next one. The next example is what is minus 5 times minus 3? So minus 5 times minus 3, the same approach. Minus times minus is plus. 5 times 3 is 15. Our answer is going to be plus 15. Plus 15. Now, plus 15 or 15. Plus 15 and 15 is still the same thing. Plus 15 and 15 is still the same thing. It means it's carrying a positive charge. Positive. It is positive. Now let's look at some steps written in our study material. Order of operations. You follow the order of operations when evaluating an expression. Step 1. Perform all work inside grouping symbols, either in parentheses and brackets. Following steps 2 through step 4 below. Step 2 is now saying find the value of parts in bracket exponents and roots. See lesson 24. We shall move to that later. Multiply or divide, working from left to right. Next step, add or subtract, working from left to right. Multiply or divide according to BODMAS. Then we have these are some of the operations. So let's look at the practice questions. Let's quickly solve all the practice questions. Now, question 1. Choose or write the answer to each question. Which of the following is equal in value to which of the following? The first practice question. Which of the following is equal in value to minus 6 in brackets, minus plus 9, plus 12, minus 4. So let's take a good look at this. It means that we are going to open the brackets. Shall open the brackets. How do you go about that? So I will start from here. Minus times minus is plus. Minus times minus is plus. I bring down the 4. Plus times plus is plus. I bring down the 12. Minus times plus is minus. I bring down the 9. Then here I have minus 6 in bracket. I bring it out. I repeat again. Minus times minus is plus. Then I bring down my 4. Plus times plus is plus. I bring down my 12. Minus times plus is minus. I bring down my 9. Then the last one is minus 6. So minus 6 minus 9. I am owing Taiwo minus 6. And at the same time, owing Kehinde minus 9. How much am I owing altogether? I'll be owing minus 15 altogether. Then here I have plus 12 plus 4. I have 12 naira. And at the same time, I have 4 naira. How much do I have altogether? That is plus 16. So if I have plus 16 and I'm owing someone minus 15, I can easily pay the minus 15 and still be left with plus 1 or positive 1. So my answer to that question is plus 1, and the correct option is option D. So question 1, the correct option to that question is 1. Let's go to the next question. Which of the following is equal in value to, we have 18 in brackets, minus 5, minus 3, plus minus 7. Now let's take a good look at this. The same approach, there's no difference. Plus times minus is minus. I bring down my 7. Minus times minus is plus. I bring down my 3. Minus times minus is plus. I bring down my 5. Then I have 18, positive 18. So I will sum this up. 18 plus 5 is 23. 23 plus 3 is 26. 26 minus 7, that will give me 19. 26 minus 7 is 19. And the correct option to that is option A. Is option A. I hope that is quite understood. Let's go to the next one. That's question 3. Question 3. Question 3 is saying that which of the following is equal in value to, I have minus 8 in brackets, minus 4 in brackets, minus 2 in brackets. So this I need to multiply through. You can, is as easy as saying minus 8 times minus 4 times minus 2. It's still the same thing. So I will multiply the signs out before I multiply the value itself. So if I'm to multiply the sign, minus times minus is plus. Plus times minus is minus. So I'm adding minus there. Then I will say 8 times 4 is 32. 32 times 2 is 64. So what option is the correct option there? You can see they want to confuse the candidates, putting plus 64 and minus 64. So the correct option is option D, which is minus 64. I repeat again, minus times minus is plus. Plus times minus is minus. You multiply the values by saying 8 times 4, that's 32. 32 times 2, that's 64. So that's how we go about that. Let's move to the next question. That's question 4. Question 4 in our practice questions. Question 4 is saying which of the following is equal in value to 6 plus 8 times 2 raised to power 2. 2 squared. 2 squared is 4. That means 2 times 2 is 4 times 8 plus 6. According to our board mass, multiplication will come before addition. So 8 times 4 is 32. Then add it to 6. You end up having 38. So 38 is the answer, which is option B. That's option B. Okay, let's go to question 5. The next practice question. Question 5 is which of the following is equal in value to minus 2 times 5 all being squared plus minus 3 times 6. Minus 2 times 5 means minus 2 times plus 5, that's minus 10, all being squared. Then plus minus 3 times 6, or you could say minus 3 times plus 6, it's still the same thing. That's going to be minus 18. So we need to square this. The analysis or the breakdown of this is minus 10 times minus 10 plus minus 18. Minus 10 times minus times minus is plus. 10 times 10 is 100. So that means minus 10 times minus 10 will give me plus 100. Then plus times minus is minus. And we have 18 here. I'll bring it down. 100 minus 18 is what? 82. And what option is 82? This is option A. I want to believe we are getting the solutions. I want to believe we are getting the solutions. So that is how we solve such. Let's go to question 6. Question 6. Now practice question. Let's go to question 6. Question 6. Which of the following is equal in value? 2 raised to power 3. That's 2 cubed. 2 raised to power 3 minus 25 over minus 4 plus 9. 2 raised to power 3. That's 2 cubed. 2 raised to power 3 means 2 multiplied by itself 3 times. 2 times 2 times 2. 2 times 2 times 2 will give us 8 minus 25 over minus 4. I'm owing Taiwo 4 naira, but I have 9 naira with me. So by the time I pay out of this 9 naira, I should still have something left. So minus 4 plus 9 will give me plus 5. Minus 4 plus 9 will give me plus 5. So I can now divide. Division comes before subtraction. So 5 in 5, 1. 5 in 25, that's minus 5. So I'm going to have 8 minus 5 in brackets. So minus times minus will give me plus, as we all have it on the board, as we all know. So bring down my 8 and my 5. 8 plus 5 is 13. So which option is 13? That's option A. Option A. Question 7 is in a word problem format. Question 7 is in a word problem format. So let's look at that together. Let's look at question 7 in word problem format. The lowest elevation of a desert is 250 feet below sea level. The highest elevation is 1,000 feet above sea level. What is the difference in height between the highest and the lowest point? What's the difference in height between the highest and the lowest point? So a hint is given. Think of sea level as 0 feet. Since it's difference, question 7, you will just say 1,000 feet minus 250 feet. 0 minus 0 is 0. 0 minus 5 is possible. Borrow 1 here. So we are left with 9. Here it turns to 10. 10 minus 5, 5. 9 minus 2 is 7. So our answer is going to be 750 feet. 750 feet. So for question 7, we write 750 feet as our answer. Now question 8. Let's look at question 8. Nita had $318 in her checking account on Monday. On Tuesday, she withdrew $60. On Wednesday, she deposited $289 and made a $50 purchase with her debit card. What was her balance after using the debit card? After using the debit card, what will be her balance? So we can quickly analyze that. The last question Then, and question 8. Question 8. So she had $318 on Monday. Then, in her checking account, on Tuesday she withdrew $60 on Tuesday. She withdrew $60 on Tuesday. On Wednesday, she deposited $289 on Wednesday. And still this same Wednesday, she made a purchase of $50 still on Wednesday. She had these two transactions on Wednesday. So it means that since she's having this on Monday and she deposited this, so we're going to sum up these two. So $308 together with $289 will be summed up. Because this one she made a purchase from a debit card. This one too she withdrew. That means she's pulling it out from her checking account. So let's add this up first. 8 plus 9 is 17. And then the 1 plus 1, 2, that's 10. And then the 1 plus this 4, then 6. That's $607. That's $607. Then 50 plus 60, that's $110. 110 will be subtracted from that amount. 7 minus 0, 7. Impossible. Borrow 1 here. We are left with 5, 10. That's 9. 5 minus 1 is 4. So invariably, Nita will have $497 as a balance after making that purchase of $50. So we've been able to tackle all the practice questions under that lesson. So we're going to move to another lesson, and the topic there is exponents. Exponents. So let's look at that critically. Exponents. So let's add the introduction. Exponents are used to simplify problems that call for repeated multiplication. Exponents are used to simplify problems that call for repeated multiplication. The expression 5 raised to the power of 3. Look at this. This is 5 raised to the power of 3. 5 raised to the power of 3. That's the expression given, which is read 5 to the third power, or 5 cubed. Is that you say 5 raised to the power of 3, or you say 5 cubed? It's still the same thing. Has a base of 5 and an exponent of 3. It means it has a base of 5. Is either you use power or exponent, and has an exponent of 3. Is that taken? So the exponent tells us how many times the base should appear in the multiplication problem. The exponent, the power, is telling us that 5 should appear 3 times. So 5 cubed simply means 5 times 5 times 5. And that will give us 5 times 5 is 25. 25 times 5 is 125. So 5 cubed is 125. Hope that is taken. 5 cubed is 125. Let's quickly look at other examples highlighted in our study material. 12 squared means the exponent is 2 of the power is 2. 12 must appear 2 times. 12 times 12, and that will give us 144. We also have 2 raised to the power of 5. It means 2 must appear 5 times. 2 times 2 times 2 times 2 times 2. That's 1, 2, 3, 4, 5. 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that's how they arrive at all those answers. That's how they arrive at all those answers. So a raised number at the right hand of another number tells how many times the number is to be used as a factor. It's being raised. 2 raised to the power of 3 means 2 must appear. 2 is the base, 3 is the power. So it means 2 must appear how many times? 3 times. To raise a number, where's my calculator? Okay, I found it. To raise a number to a higher power, there's a sign on the calculator. I'm going to show you. There's a sign on the calculator. There's a sign like this on your calculator. So to raise a number to a higher power, use this sign. For instance, 5 raised to power 3. Let me show you on your calculator. You see something like this. It's here on your calculator. See the symbol. Can you see it? This is the symbol here. So if you say that, if you're on your calculator, then you say 5 raised to power 3 to give you 125. I repeat it. 5. This is the raised to power. Raised to power 3 to now give you 125. Is that taken? 5 raised to power 3 is in our calculator. So then where we are supposed to use that, maybe we have 6 raised to power 12. So we quickly use it instead of us breaking it down. If it had been a bigger number, 6 raised to power 5, we keep multiplying and that may take our time. Are you getting it? So we could use the calculator in achieving that. So to raise a number to a higher power, use that key, this symbol here. This symbol, we use it. It's in our calculator. But as we progress too, we can also use exponential. There's what we call exponential. So an exponent can also be 1, 0, or a negative number. Remember, any number with an exponent of 1 equals itself. Any number with an exponent of 1 equals itself. So what they are trying to say there is that if I say 2 raised to power 1, this is the base, equal to 1. It means it's appearing just once. It's still 2. 9 raised to power 1 will still be 9. 7 raised to power 1 will still be 7. Is that taken? But any number raised to power 0, 4 raised to power 0 is 1 according to one of the laws of indices. Any number raised to the power of 0 is 1. It can be proven. 3 raised to power 0 is 1. Then 10 raised to power 0 is also 1. I want us to take a good look at all this. They are simple principles. Our number system is based on the idea of grouping by tens. Powers of tens are especially important. So let's look at these powers of tens. Now we have 10 raised to power 1 will give me 10. 10 raised to power 2. We already have the idea. The power is 2, the base is 10. 10 multiplied by 10. That is 100. We have 10 raised to power 3. We give it 10 appearing 3 times. That is 1000. Then 10 raised to power 4 is 10 times 10 times 10 times 10. That's about 10,000. Well, 10 raised to power 4 must have 4 zeros. That's what it means. 10 raised to power 3 must have 3 zeros. That's why we're having it as 1,000. 10 raised to power 2 must have 2 zeros. That's how we have 100. 10 raised to power 1 must have 1 zero. And that is why we're having 10 in that concept. So we could have negative ones, negative powers. Negative powers of 10 are useful for writing very small numbers. Any number to a negative power represents a fraction or decimal. So let's, just as we have this, if I have 10 raised to power minus 1, according to the law of indices, it means 1 over 10. 1 over 10. And 1 divided by 10 is 0.1. It means that if I have 1 here, there's an imaginary point. Move it to the left once, add your 0. That will give us 0.1. Add 1 here with an imaginary point. Why am I moving it once? It is because I have only 1 0. I'll move it once to have 0.1. Let's go to the next one. 10 raised to power minus 2 means 1 over 100. So it means if I have my imaginary 1 here, if I have my 1 and there's an imaginary point, I'll move it how many times? 2 times, because there are 2 zeros. So if I'm to move it 2 times, it's going to be 1, 2. My point is now here. Add 0 here, add 0. So I'll end up having 0.01. Is that taken now? So 10 raised to power minus 2 is still the same as 1 over 100, and it will still give us 0.01. So let's take another one. 10 raised to power 3, 10 raised to power minus 3 is still the same thing as 1 over 1000. So it means I'm moving my decimal how many times? 3 times. 1 imaginary point here. 1, 2, 3. Look at where the point is. Put 0, 0, 0. So I'm going to have 0.001. So the number of zeros determine your movement. So 1 over 1000 will give me 0.001. So now, if we have a large number, because what we are moving to now, want to discuss scientific notation or scientific or standard form, ordinary form and standard form. We are gradually moving to ordinary form or standard form. Scientific notation, a way of writing very large numbers and very small numbers, in which the numbers are expressed as products of a number between 1 and 10 and a power of 10. Standard form. When you're expressing a number in standard form, it means that you can say 8 times 10 raised to power n, where a falls between 1 and 10. 1 and 10. Then n is the power. N is the power. That's what the statement is saying. N is the power. Is that taken? So, scientific notation is a method that uses power of 10 to write very small and very large numbers. If you have large numbers, so we have to write it in standard form or in scientific notation. Is that taken? So, because you cannot write 480 billion, it will take time, but we can express it in standard form. It will make it quite easier and simpler as well. So that's what scientific notation is trying to tell us. A number in scientific notation is expressed as a product of a number between 1 and 10, product of a number between 1 and 10, and a power of 10. Let's take for instance, we want to write this large number. It could be a large number, and at the same time, it could be a small number. So if we have a large number like this, 0, 0, 1, 2, 3, 1, 2, 3. If you are to write this in scientific notation, or what we call standard form, that's another name of calling it standard form. Is either it is a scientific notation or standard form. So we have to move this. There's an imaginary point there. Let's move it until we get to second to the last number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the point is now here. So I have 4.9. How many times have we moved the decimal? Move the decimal 9 times. Times 10 raised to the power 9. So that is the expression here. We said A must be between 1 and 10. 4.9 is between 1 and 10. Then n is the power. The number of times you move the decimal, power. So this is scientific. We have been able to represent from an ordinary number or ordinary form to a standard form or scientific notation. Now, the same goes for decimal with negative power, the one that gives us negative power, 0.0055. You know, we move from right to left. If we are moving from left to right, it's going to be a negative value. So let's take a good look at this. 1, 2, 3. So this is going to be 5.5 times 10 raised to the power minus 3. 5.5 times 10 raised to the power minus 3. So it is negative. You remember that we said this can also be further broken as 5.5 times 1 over 10 raised to the power 3. What we did earlier. So we have 5.5 times 1 over 10 raised to the power 3 is 1000. So if I say 5.5 times 1, that's 5.5 over 1000. I'm moving this decimal back. How many times? 3, because there are 3 zeros. 1, 2, 3. So the decimal is there. Put 0 here, 0, 0. So you discover that 0.0055. We've gotten back our question. This is our answer, but I did a reverse fixture. To get back my question. So 0.0055. Move your decimal from your left. Once you move from left to right, you have a negative number. So that is why that is a negative value. So we shall quickly look at okay, let's say this. The distance, example 1, the distance to the sun is about 93,000 miles. Write the distance in scientific notation. 93 million miles. Example 1, the first example in our study material, we have to write 93 million miles in scientific notation. Scientific notation meaning that I want to write this in standard form. It's quite easy. Put your pencil or your biro here. Then let's move 1, 2, 3, 4, 5, 6, 7. So that will give us 9.3. Since we have moved 7 times, times 10 raised to the power 7 miles. That's the answer in scientific notation, or simply put, in standard form. So the other one, in scientific experiment, the mass of a sample is 2 times 10 raised to the power minus 5 kilograms. 2 times 10 raised to the power minus 5 kilograms. And write the mass in standard notation. Standard notation in this regard, meaning in ordinary form. Write it in ordinary form. So just as we did earlier in ordinary form, it means that it is still the same as 2 times 1 over 10 raised to power 5, right? So this is still 2 times 1 over 10 raised to power 5. Just put your 5 zeros. That's 100,000. Is that not? Then you have 2 times 1 is 2 over 100,000. So it means we are going to move from here 5 times to the left. So if I'm moving 5 times to the left, let's see. My imaginary point is here. 1, 2, 3, 4, 5. This is where my point is. Put 0 here. 1, 2, 3, 4. So I'll end up having 0.00002 as my answer. Since it's in kilogram, you put your kilogram. Is that taken? So that is what they did there. So let's note this. If you perform operations that result in a very large or very small number, this is a very small number. 2 times 10 to the power minus 5 is very, very small. 193 million is very, very large. It could be more than this. It could be in billions. It could even be in zillions. So if it is in zillions, you have to present your answer in standard form. If you multiply two large numbers in your calculator, you discover that your final answer will be given in scientific notation. To be given in scientific notation to make it easier. So let me read this note. If you perform operations that result in a very large or very small number, your calculator may display the solution in scientific notation, just as I was trying to explain. Enter this operation, 30,000. So can you please punch your calculator? 30,000 multiplied by 5 million. If you punch it from your calculator, can you please do that quickly? In the next 60 seconds, quickly punch this while I will do it or solve it manually. If I have to solve this manually, I'll just say 3 times 5, because these are the two whole numbers there. 3 times 5 is 15. Then how many zeros do we have? How many zeros do we have? How many zeros? We have 6 zeros there, and we have 4 zeros, making 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 zeros. And I can move my decimal as we've been doing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'll end up having 1.5 times 10 to the power 11. What do you have in your own calculator when you punched it? I'm sure your answer must be the same as mine. Isn't that so? Okay. You got the same thing? Alright, perfect. Okay, let's continue, please. Since we're having the same answer, that shows we're on the same page. Let's quickly do justice to the practice questions now. Let's do justice to the practice questions. Choose or write the answer to each question. Do not use a calculator. So we've been instructed not to use a calculator. Question 1, let's run through 2 raised to the power 4. The base is 2, so it means 2 times 2 times 2 times 2. Let's go. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Our answer is 16, and that's option D. Question 2, 4 raised to the power 3. It means 4 should be multiplied by itself 3 times. 4 cubed. 4 times 4 is 16. 16 times 4 is 64. And what option is that? The correct option is also option D. Question 3. 16 raised to the power of 1. And we said this earlier, that any number raised to the power of 1 is still that same number. That's option C. Question 4 is 1 raised to the power of 6. It means 1 times 1 times 1 times in 6 places. 1 being raised to the power of 6 will end up giving us 1. And that's option B. So Question 5 is saying 5 raised to power 0. From our principle, any number whatsoever being raised to the power of 0 is 1. So the correct option is option C. Then the last question on that category is 3 raised to power minus 2. 3 raised to power minus 2 is still the same thing as 1 over 3 raised to power 2, as we all know. So it means 1 over 9. Which option gives 1 over 9? That's option B. So if option B gives that, shall we continue? Question 7. Question 7 says the distance across the sun, its diameter, in scientific notation is 8.65 rather. 8.65 times 10 raised to power 5 miles. That's the distance across the sun in scientific notation or in standard form. What's the distance written in standard notation? What will be this distance written in ordinary form? We want to write this in ordinary form. 8.65 in ordinary form. There are 5 zeros. That means I will move 5 steps forward. 5 steps forward. 8.65. I'm going to say 1, 2, 3, 4, 5. The decimal is now here. Put zeros there. So I'll end up having 865,000. Can you see what I did? I moved 5 steps forward. 1, 2, 3, 4, 5. That's going to be 865,000 miles. 865,000 miles. How many? Which option is that? The correct option is option C. The correct option is option C. Now, the next question is number 8. Number 8, in a very dense fog, a person can see about 0.019 mile. So what is this distance written in scientific notation? In a foggy weather, where the level of visibility is very, very poor as a driver. If you are driving in a foggy weather, you will not be able to see clearly. So we're told that the level of visibility of that person is 0.019 mile. So we have to present this in scientific notation or in standard form. So what do? You move your decimal forward 1, 2. So you end up having 1.9. How many times have we moved it? 2 times, but it's a negative value. So 1.9 times 10 to the power minus 2. We moved it twice. 1, 2, 1.9. And the correct option there is option A. Option A is the correct option. Option A is the correct option. So I'm going to give you a task. Question 9. You're going to solve question 9. Arrange the given numbers in order from least to greatest. From least to greatest, that means from smallest to the biggest number. 5.4 times 10 raised to the power 2, 3.02 times 10 raised to the power 3, 9.55 times 10 raised to the power minus 2. So you have to arrange these 3 numbers accordingly from smallest to biggest. That's going to be your assignment. Choose the option that best completes this sentence. Look at this sentence. So 4.2 times 10 raised to the power 3 is it more than 42,000? Is it equal to 42,000? Is it less than 42,000? So these 2 questions will be your takeaway questions. In our next class, we shall look at square roots and cube roots. Please try and go through all our discussions. We'll see in our next class.